Okay, let's talk about inverses. Basically what inverses do, it allows you to switch the x's and the y's. So where a normal equation, you will start with the independent value and solve to get the dependent or the y value. You can now switch it around and you're able to rewrite the equation so that way you're able to start with the final answer and work backwards to see what makes it true. So here's what should happen. When you have inverses, what should happen is if you do a composition into the other, you should get the equation to come out to equal x. So on example 1, what we're going to do is we're going to do two separate compositions. So notice what I have here is I'm substituting g of x into f, and when I work it out, I get x minus 2 plus 2, which ends up equaling x. So far, this has a potential to be an inverse. Now I got to do the inverse, or the composition with g of f of x. So now when I do that, I have x plus 2 minus 2, which gives me x. So since f of g of x and g of f of x both come out to equal x, this is an inverse. So f and g are inverses of each other. I'll let you read through this part in here, but let's go ahead and talk about how to tell if a graph is an inverse, or how to find the inverse. Basically, rule 1 is to replace f of x with y, switch the x and y's, and the math part comes into play when you have to solve the equation for y. And then we'll replace y with f to the inverse negative 1x. So this is your inverse notation. So let's take a look how this works. So with rule 1, I replace y with f of x. Second rule is to replace the x and y's. So switch the x and y values, and so that's what I did. Now I'm going to work on the third rule, which is to solve for y. When I cube both sides, I get x to the third equals y minus 5. Now I have x to the third plus 5 equals y, so I have the inverse done. And my final step is to replace f inverse with the y with f inverse notation. So since I started with function f, this would be f inverse of x equals x to the third plus 5. So now with this notation, I know I just found the inverse of f. Now when you have a fraction, it gets a little trickier. You still want to follow the same rules, but you just really want to be careful. Pay attention to this one because you will see this one on test. First thing I want to do is replace g of x with y. So I get y equals x minus 4 over x plus 2. So now when I switch the x and y's, I get x equals y minus 4 over y plus 2. And now here comes the tricky part, solving this for y. So what I'm going to do now is I'm going to use my proportions. I'm going to cross multiply. And when I do that, I get the following. So I have y minus 4 equals x times y plus 2. I need now to distribute the x, and I get the following. So now here's the part you want to pay attention to. The goal is to get the y's by itself. So you get that y and this y all on the same side. So when I do that, I'm going to have to probably go ahead and move the xy over to the other side, and then I'm going to move the minus 4 over to the other side, so it'll look like this. So now I'm just about done, but now here's the important part. Notice they both here on the left side, they both have a y in common, so we're going to factor out that y. When I do that, I get a 1 minus x equals 2x plus 4. Notice I now have the y isolated. So now all I got to do is divide by 1 minus x. And so I end up with y equals 2x plus 4 over 1 minus x. And now for my final step is just to replace the y with the inverse notation. And remember, since we started out with a g originally, this would be g inverse of x equals 2x plus 4 over 1 minus x. And that's it.